This lesson is on algebraic tree diagrams and using algebra in probability tree diagrams to calculate probability. This also shows you, the slide also shows you your equipment that you'll need for this lesson and the keywords that we've looked at already, and again we'll be referring to in this lesson. In this first example, we've got a box that's got 4 counters with some purple and some pink, and counters are chosen at random. So we've got 2 counters. First choice, choose a counter and random, then it's been replaced, and then they've chosen another counter, and we're told that the probability of choosing 2 counters is 1/16. Now for this first part of this question, we know that there's 4 counters in total, but we don't know how many there are of each purple and pink. So if I say that for purple that there's X amount of counters for purple, so therefore when I come to write the probability for purple, it'll be X over 4, so number of counters divided by the total. Now for pink, because there's 4 counters in total and there's X purple, if I subtract the 2 numbers, okay, the 2 values, so that'll be 4 take away X. So now the probability for the pink will be 4 take away X divided by 4. So that gives me the probability for the pink as well. So now because they're being replaced, so therefore the second part, on the second choice, the probabilities will be the same. So again I'll get X over 4 minus X over 4, and again that's X over 4, and 4 minus X over 4. So now I've got the probabilities for the tree, and then what we're told is the probability for 2 purple counters is 1/16. So that means it will be purple and purple. So if I first part use the algebraic fractions to work this out. So the probability to get purple and purple, purple and purple, is equal to X over 4 times X over 4, which is X squared over 16. Now what we also told is that the purple probability for the 2 purple counters is 1/16. So therefore we've got X squared over 16 is equal to 1/16. Now the denominators for both are the same, so therefore X squared has to equal 1. So therefore if I square rooted the X squared, that will give me X is equal to 1 or minus 1. So remember, you get, when you square root you get 2 answers. Well, we can't have -1 counters in the box, so we're not going to, so here we're not going to use the negative value, so therefore X is equal to 1. So once we've got the value of X, I can put this back into the question. So now I've got the exact, I can work out the exact value of counters and the exact value of the probability. So here I will now have 1/4 for the probability of the purple. So therefore that will then give 3/4 for the pink. And again here 1/4 and 3/4, 1/4, 3/4. Now once I've got these probabilities, I can now use my probability rules to work out the value of any combinations that I need. So for example, I can work out the probability of getting the same color, so 1/4 times 1/4 plus 3/4 times 3/4, and things like that. Okay, so the rest of it will be very similar to what we've looked at already. So for this question, what we find is that there's 1 purple counter and there's 3 pink. What I would like you to do now is pause this video, try this question for yourself, and once you've done your answer, play the video, and then I'll go through the answer. So for this question, in the pencil case, they've got a total of 8 pencils. So the denominator for the two fractions will be 8. And if you use x as the number of red pencils, so therefore we'll get x over 8. And the rest are green. So therefore, the number of green pencils will be 8 minus x. 8 minus x, okay, divided by 8 for your fraction. And because they're being replaced, the terms in your fraction will be the same for each part of the tree. Next, we're told that 2 red pencils, probability for those is 49 over 64. So that means we're looking at red and red. So if I calculate the probability for that using the algebra, I will get x squared over 64. And if I compare that to the actual answer that we've been given, therefore x squared will equal 49. Denominator is the same there, x squared. So if I square root 49, what you remember, you'll get positive 7 and negative 7, and you'll need to use the positive value since you're not going to get minus 7 pencils. So therefore x is equal to 7. I'm going to substitute that back in. So now that will give me x over 8 is going to become 7 over 8, 1 over 8, and I can then work out the actual values for the tree. And then question asks find the probability for one pencil of each color. So I'm looking for red and green or green and red. So I've got two possibilities. 2 outcomes that I'm going to use. So here, probability of red and green, or the probability of green and red. Work out those probabilities, and you get an answer of 14 over 64. In this example, we've got 6 counters in a bag, and again we're told some are blue, the rest are pink, and we're also told that 2 counters are chosen at random from the box. So from this statement here, that shows that the counter is not replaced back into the box. So they take one and then they take a second counter without replacing it in the box. So that's what taking 2 counters means. Okay, and we also told the probability for picking 2 blue counters is 2/5. So first part, if I call the number of blue counters as x, so therefore the probability of picking out blue will be x over 6, and for the pink counters, well, if there's 6 counters altogether, 6 take away the number of blue, so that's 6 take away x will tell me the number of pink counters. So here it's 6 take away x, all divided by 6 for the probability for pink. So now we've got the probability for the first choice of blue and pink. Now for the second counter to be chosen, now because there were 6 at the start, now our denominator now is 5 because there's now 5 counters left in the bag. So with if the first counter chosen was a blue, that means we now have 1 less. So therefore the numerator will be 1 minus x minus 1. So x minus 1 divided by 5. And for the pink, again, it still stay the same as 6 minus x over 5. And for the other option, if the pink counter is chosen first, so therefore there's still x amount of counters for the blue left, but there's only 5 counters left in the bag, so that's x over 5. And for the pink, again, it'll be 6 minus x minus 1. So we're taking one away from the pink because we've taken 1 out. So therefore that'll be 5 minus x, all divided by 5. So now we've got the algebraic probabilities for each part of the tree. So next part, we're going to now look at using this bit of information that we've got here. 2 blue counters, probability for the 2 blue counters is 2/5. So if I follow the path for the 2 blue counters, x over 6 multiplied by x minus 1 over 5. So here, if I work out the algebraic term for the probability of the 2 blue counters, so probability to get blue and blue is equal to x over 6 times x minus 1 over 5. Now for this part, I'm going to put that into brackets. So using my multiplying algebraic terms, we'll just multiply these out. So that'll be x times x will give me x squared minus x, and all divided by 30. 6 times 5 equals 30. That's my denominator. And all of this is has to equal that, because that's looking at the same probability. So that is equal to 2/5. So now we've got an algebraic equation that we need to solve and work out the value of x. So first part, if I get rid of the 30 and the denominator, so if I multiply both sides by 30, so that times 30 times 30, okay, I will be left with x squared minus x is equal to 2/5 times 30. 2/5 of 30, 30 divided by 5, 6 times 2 equals 12. So now I've got x squared minus x is equal to 12, minus 12 on both sides. So that's x squared minus x minus 12 equals 0. So now I've got a quadratic equation that I can solve, and I can solve that by factorizing. So here, start off with x in the double brackets, x in both terms, both parts, and I need two numbers that multiply to give me minus 12 and add to give me minus 1. So here it'll be 4 and 3 and to give the 12. So if it's 4 and 3, so to get minus 1 from there, it's 3 minus 4. So positive 3 minus 4. So that also gives multiply to give minus 12. 3 take away 4 is equal to minus 1. So if I now solve these brackets, so now I'll have either x plus 3 equals 0 or x minus 4 equals 0. So therefore x is equal to minus 3 or x is equal to 4. Now for this part again, remember we can't have minus 3 counters in the bag. Okay, so it has to be a positive value. So therefore we can't use that value there. So therefore x has to equal 4. So if x is equal to 4, and we're going to substitute that back into our algebraic terms, or to work out the probability, so therefore x is equal to 4. So the probability here will be 4 out of 6. X 6 take away 4, therefore that gives me 2 over 6. Here now we've got 3 out of 5, and this is 2 out of 5, and that's x, so x is 4 over 5, and the last one, it's 1 out of 5. So now I've got the actual values of each of the probabilities in the tree, and I can now use these values to work out the last part of the question. Work out the probability for getting at least one pink counter when 2 are chosen at random. So I'm gonna list first part. List out all the outcomes. So I've got blue, 8 over 30 plus again 8 over 30 plus 2 over 30. So that gives me 8, 16, 18 over 30. So what I would like to do now is pause this video and try this question. And once you've completed the tree and completed the question, play the video and then I'll go through the answer. If you call the number of pens for black as x, so therefore probability for black pens is x over 9, and the probability for the red pens will be 9 minus x divided by 9. And for the second, when the second pen is chosen, you'll end up with x minus 1 over 8 9 minus x there, 9 minus x over 8 has the probability there, and then you'll get x over 8 and x minus 8 minus x over 8 for the red. Over 72, and 2 times 7, again 14 over 72, so therefore that's 28 over 72 is what you should get. So for the main task of this lesson, I would like you to do one of these questions from the red, one of these questions from amber, and one of the questions from green. So there's 3 questions in total, one red, one amber, one green. Once you've completed your work, take a picture of your work and upload it onto class charts for you to have completed the work for this lesson.